Welcome to day 16, AMI. Today we're going to talk about complementary and supplementary angle identities. First, what are complementary angles? If alpha and beta are complementary, then alpha plus beta equal 90 degrees, or alpha plus beta equal pi over 2 radians. We look at the circle and an angle on the circle. If this angle is alpha, then this angle would be beta if alpha and beta were complementary, because alpha plus beta make a 90-degree angle, or pi over 2 radians. If I ask you to find an angle complementary to 37 degrees, you would say alpha, let's just call this angle alpha, plus 37 equals 90 degrees. Subtract 37 from both sides. Alpha equals 53 degrees. If I said find an angle complementary to pi over 5, pi over 5 radians, then you would say alpha plus pi over 5 equals pi over 2. Subtract pi over 5 from both sides. Get a common denominator. Pi over 10 minus 2 pi over 10 equals 3 pi over 10. That would be my complementary angle to pi over 5. Supplementary angles are two angles that add to 180. So if alpha and beta are supplementary angles, then alpha plus beta equals 180 degrees, or alpha plus beta equals pi radians. So if I said find the supplementary angle, to 37 degrees, you would say 37 plus alpha equals 180. Subtract 37 from both sides and get alpha equals 143 degrees. If I ask you to find an angle supplementary to pi over 5, radians, you would say alpha plus pi over 5 equals pi. Subtract pi over 5 from both sides. Remember, pi is the same as pi over 1. We made a common denominator, so multiply by 5 over 5, and we get 5 pi over 5 minus pi over 5 makes 4 pi over 5, and that's an angle supplementary to pi over 5. So we're looking for identities, and we're going to go back to the unit circle. If we have an angle alpha, then a complementary alpha, if alpha plus this angle equals 90, then this angle is also 90 minus alpha, or pi over 2 minus alpha, if we're given radians or degrees. But either way, we'll find the complementary angle identities. if we recall, that for alpha, the x-coordinate on the unit circle is cosine alpha, and the y-coordinate, is sine alpha. If we look at this, if this angle is alpha, and this is 90 minus alpha, if we moved alpha to where this angle was alpha, then now this angle becomes 90 minus alpha. This was the sine of alpha, and due to symmetry on the circle, this one's symmetrical about the line y equal x. It's a reflection across there. This is the cosine of 90 minus alpha, but it's congruent to the sine of alpha. So that means the complementary angle, identity for the cosine of 90 minus alpha, is equal to sine alpha. And this distance was the cosine of alpha, the x-coordinate. It is now congruent to the y-coordinate of 90 minus alpha, so the cosine of alpha is equal to sine of 90 minus alpha. So sine 90 minus alpha is equal to the cosine of alpha. Because the y-coordinate of 90 minus alpha is congruent to the x-coordinate of alpha, and the x-coordinate of 90 minus alpha is congruent to the y-coordinate of alpha. Now that we have cosine 90 minus alpha and sine 90 minus alpha, we can find the tangent of 90 minus alpha. That's equal to sine 90 minus alpha over cosine 90 minus alpha. We said sine is 90 minus alpha is cosine alpha, and cosine 90 minus alpha is equal to sine alpha. So the tangent of 90 minus alpha is equal to cosine alpha over sine alpha, or cotangent alpha. So now we can say the secant of 90 minus alpha is equal to 1 over the cosine of 90 minus alpha, and that's equal to 1 over sine alpha, so that's equal to the cosecant of alpha. And the cosecant of 90 minus alpha is equal to 1 over sine 90 minus alpha. Sine 90 minus alpha is cosine alpha, so it's 1 over cosine alpha. That's just secant alpha. And all these are by definition. Cotangent 90 minus alpha is equal to 1 over tangent 90 minus alpha. That's 1 over cotangent alpha. That's the reciprocal of cotangent alpha, and the reciprocal of cotangent alpha is just tangent alpha. So the complementary angle identities, I don't advise you to try to memorize all these, but build them from the circle like we did here. Sine, I'm going to put them in radians now, pi over 2 minus alpha is the same as cosine alpha. Cosine, pi over 2 minus alpha is the same as sine alpha. Tangent, pi over 2 minus alpha is cotangent alpha. Go ahead and do cotangent. Pi over 2 minus alpha is equal to tangent alpha, and cosecant pi over 2 minus alpha is equal to secant alpha, and secant pi over 2 minus alpha is equal to cosecant alpha. And those are our complementary angle identities. We're going to go ahead and do the supplementary angle identities. These are true no matter where the angles are on a plane. We're using the first quadrant just because it's easier to see, but this is true. We'll show later with any angle, anywhere on the plane, on the circle. This is the unit circle. We take an angle alpha. Notice this is not 45 degrees necessarily, it's just alpha. The x-coordinate here is cosine alpha. The y-coordinate is sine alpha. By definition, this angle is 180 minus alpha, or pi minus alpha. So pi minus alpha and alpha, or 180 minus alpha and alpha, are supplementary angles. But notice, if we took this angle and just started at 0, it would be a reflection of this angle across the y-axis. So the cosine of alpha, this distance would be congruent to this distance. That would make, this is cosine pi minus alpha, sine pi minus alpha. But the cosine of pi minus alpha is this. It's congruent to this, so this is, the only thing different is the SIGN sign. This is negative cosine alpha. So cosine pi minus alpha is equal to negative, cosine alpha. And the sine of pi minus alpha, sine of pi minus alpha is the same as sine alpha, because these two are congruent, they're both positive. So here we would say sine pi minus alpha, or 180 minus alpha, is equal to sine alpha, and cosine pi minus alpha is equal to negative cosine alpha. Let's verify these on the calculator real quick. Let's look at a couple numbers. Let's go ahead and do it in degrees just because it's easier to subtract from 180 than it is. So I'm going to go mode, make sure I'm set on degrees, and let's do an example. Let's say the sine of, let's do 56 degrees. And that's 0.829. We'll just leave it at 0.829. If this is true, supplementary angle is 124 degrees. So that should be equal to the sine of 124 degrees. Let's check that out. And it's the same thing. Cosine 56 equal to 0.5592, let's say. Then that should be equal to the opposite of cosine 124 degrees as far as identities are correct. So let's do cosine 124, and we see it is negative 0.5592. So we can look at this and say the tangent of pi minus alpha is the same as sine pi minus alpha over cosine pi minus alpha. That's equal to sine alpha over negative cosine alpha. That's equal to negative tangent alpha. Cotangent pi minus alpha is just 1 over tangent pi minus alpha. That's 1 over negative tangent alpha. 1 over tangent alpha is a reciprocal, so that's just negative cotangent alpha. And the cosecant of pi minus alpha is equal to 1 over sine pi minus alpha. That's 1 over sine alpha. So that's equal to the cosecant of alpha. And the secant of pi minus alpha is 1 over cosine pi minus alpha. That's 1 over negative cosine alpha, which is negative secant alpha. So our supplementary angle identities are sine pi minus alpha, or 180 minus alpha, equal to sine alpha. Cosine pi minus alpha equal to negative cosine alpha. Tangent pi minus alpha equal to negative tangent alpha. Cotangent pi minus alpha equal to negative cotangent alpha. Cosecant pi minus alpha equal to cosecant alpha. And secant pi minus alpha equal to negative secant alpha. So for these, I could ask you to find sine pi minus alpha, cosine pi minus alpha, tangent pi minus alpha, cotangent pi minus alpha, cosecant pi minus alpha, and secant pi minus alpha. If I gave you alpha equals let's say 0 is less than alpha is less than pi, and cosine alpha is negative 1/3. So we look at this, and if cosine alpha is negative 1/3, that means we're somewhere over here. Here's alpha. Cosine alpha is negative 1/3. We can use the Pythagorean identities to find sine alpha. So sine squared alpha plus cosine squared alpha equals 1. That's sine squared alpha plus 1/9. Negative 1/3 squared is 1/9 equals 1. If I subtract 1/9 from 1, which is 9/9, I get sine squared alpha equals 8/9. And the sine of alpha is equal to the square root of 8 over 3, which reduces the 2 squared to 2 over 3. We'll use it some here probably. So now I'm going to use my identities that tell me that the sine of pi minus alpha is the same. Oh, this is positive because up here this one's greater than 0, so we took the positive square root. So the sine of alpha, according to my identities, where we said that sine of pi minus alpha is sine of alpha, this is going to be 2 square roots of 2 over 3. And the cosine of pi minus alpha is the opposite of cosine alpha. Since cosine alpha was negative 1/3, cosine pi minus alpha is going to be 1/3. Tangent of pi minus alpha is going to be negative tangent alpha. We could just go ahead and use this also though, because this is going to be tangent pi minus alpha is going to be sine over cosine here. So it's going to be 2 square roots of 2 over 3 divided by 1/3. That's equal to 2 square roots of 2 over 3 times 3 over 1. The 3's cancel and leave me with just 2 square roots of 2. Cotangent of pi minus alpha is going to flip that. So that's going to be 1 over 2 square roots of 2. I'm going to multiply top and bottom by square root of 2 over square root of 2. That's going to give me square root of 2 over 2 times square root of 2 times square root of 2 is going to give me 4. So square root of 2 over 4. Cosecant of pi minus alpha is going to be reciprocal of sine. So let's flip that. 2 square roots of 2 multiplied by square root of 2 over 2 to the rationalized denominator. And that's going to give me 3 square roots of 2 over 2 times square root of 2 times square root of 2 is 4. And the secant, we're going to flip the cosine and just get 3. And that's how we'll do some of this.